Good afternoon, friends, and welcome to today's session on feature engineering for deep learning. Feature engineering is often called as art and science of machine learning. It bridges raw data and high performing models. In deep learning, while we automate some parts of feature extraction, thoughtful engineering still plays a crucial role. So now, in today's lecture, we are going to understand about how we can use this feature engineering and what is the architecture of it, how we can use it. Okay. So here we are going to discuss about data preparation and splitting, feature constructions and selection, feature transformation and encoding, building the feature set and integrating this with the deep learning models. Okay. So here, firstly, we are having a deep raw data, deep learning project. Let's start with a deep learning project wherein we will have a raw data. This can be in a structured format like rows and columns, like hospital records, retail sales, all these things. It can also be in semi-structured format like in JSON logs. It can also be in unstructured format like images, text, audio. All these are in unstructured format. So our raw data can be on any of these formats. The first step here is data preparation, like cleaning, text conversion, standardization, and checking the quality of this. Once we prepared this, we will move to data split, splitting the data into training, validation, and test set. This will ensure our model will generalize well. Next, we will tackle with missing values. If, for example, techniques like mean, median, interpolation, imputation for numerical data, mode imputation for categorical data, or advanced methods like KNN or model-based imputations will be there. Apart from this, we can have a data augmentation techniques. In deep learning, we will have a augmentations like rotation. When it comes to image data, we will apply some. If our data set is lesser, we can apply rotation, flip, crop. Likewise, we can apply. And there are multiple data augmentations technique available. Likewise, if we have a text data, we can use back translation, multiple other things we can apply. And in test series, in time series data set, if we will have our window slicing, okay, we can use window slicing, we can use jittering. Likewise, we can use. Augmentation artificially expands the data set and it improves the robustness in the data. Likewise, once our data is cleaned and we have moved forward for feature construction then. What is feature construction? This is where we will create a meaningful signals from raw attributes like manual feature creations, like domain expert design features. For example, in healthcare, BMI, we have a BMI report, we have an age groups, we have a dosage ratios. Okay, for particular age group, we will give this much dose. Likewise, in finance, we have credit utilizations, moving averages, all these things are there. So these are the manual feature creations. Likewise, we can have a automated feature extractions also. Here, we will leverage tools like deep feature synthesis, feature tools, AutoML, or representation learnings from models like CNN and transformers. After construction, we will need to select and evaluate features because more feature leads to better performance. Redundant or noisy features can hurt the generalizations. Okay, so here we will choose feature selection methods. Okay, what are the different feature selection methods? It includes feature methods like correlation, okay, chi-square, wrapper methods like recursive feature eliminations, embedded methods like lasso regularization, tree-based feature importance. All these things will come under feature selection methods. After understanding what feature, what method we have to choose, finally, iterative refinement we can adapt. This is never one shot. We experiment, evaluate, and refine. and keep improving this feature set again and again. Okay. So let's consider, for example, if we are having an e-commerce data set. Okay, raw data may have transaction logs. Manual features could be average bucket size and so on and so forth. While automated extraction features may use embeddings of the customer's review. What reviews, like what are the reviews for this particular e-commerce data set? Or what is for that particular product, what are the reviews? Okay. So this is the thing. Then we are having a feature transformation and encoding. Okay. So here now that we have selected the features, we must make them machine friendly also. That's where feature transformation and encoding will come. Encoding categorical variables, wherein we are having one hot encoding for nominal categories and ordinal encoding with natural order exist, or target encoding or embeddings for higher cardinality features. Normalizations and scaling. Min-max scaler, or we can use activation functions like sigmoid, tanish activation functions. We can have a standardizations like z-squares for models. Robot scalings can also be useful for outliers if there are certain outliers present. All these things we can adapt. Okay. Then we can have dimensionality reductions. We can use it by using PCA, principal component analysis, compresses the features while retaining the variance. Then feature selection techniques will be depending upon the domain specific methods. Okay, like what wavelength transforms for audio, if we are doing it for audio or for the textual data. What, for example, if we are using wavelength is generally useful for audio if there is certain audio to speech if we want to convert, or if there is ACR to TTS we want to convert. Likewise, we can use this audio technique. For if there is a textual data, we can use TF-IDF. All these things we can use. Then at the end, we are having embeddings. These are the powerful in deep learning models. Word embeddings like word to vec, globe, sentence embeddings, image embeddings. These will be playing important role here, which will be taking the data into dense and it will form a semantic vectors from there. Okay. After this, we are having an integration with deep learning models. Like how we are going to integrate with the deep learning models. Okay. There are multiple pre-trained models also available. If there is structured data, if there is unstructured data, if in unstructured data, the data is related to images, audios, text, all these things. For there are different pre-trained models available. Okay, so from that particularly, we will use right model for our business problem. Okay, likewise, once we have selected a model for tabular data, for like image data, we can use CNN. For textual data, we can use transformers. If we have combined this engineered features, we will have a raw data representations. And we can use it for different purposes like fraud detection, transaction embeddings, all these things we can use. Also, we can use it for model training. After training this particular thing, we can, after using it, if after getting this output, we have understood that this is a right fit model, we can use it for model training. Okay, if that data is balanced, if this is a right model, giving a right accuracy, we can use it for training as well. Like for example, in healthcare demand forecasting engineered features, we are having days of week, holiday flags, all these things are there, which will be combining with the embeddings from the past prescription. Okay, which will be describing from the past description based upon what feature or what treatment we have to give it to this particular patients. If this person is allergic to certain like certain medicine, certain drug or likewise. Okay, so in today's lecture, we have understood about raw data, how we can take this raw data and how this raw data can be, it can be in a structured or unstructured format. Then we have understood about how we can do this data pre-processing. for multiple cases. If the data is structured, again, the data is structured or unstructured. We have understood about augmentation techniques. We have understood about how we can construct and select this features. We can use it by manual methods also. We can use it by automated methods also. Okay. Likewise, we can transform and encode this, and we can use it for multiple things like encoding, scaling the data set, reducing the dimensions in the data set, embedding, formation of this embedding if our data set is in textual format. All these things we can do here. After this, once we have finalized our feature is ready, okay, whatever the features or X inputs we are going to send, if this is ready, we can use it for integrating this model, integrating with this deep learning models. Okay. Likewise, there will be multiple deep learning models. From that deep learning models, we are going to choose any of whatever will be giving us a better accuracy. We can move further with model training, then model evaluations, then again checking this, again going backward, doing back propagations, all these things. Once we'll get the accuracy which is good and the losses which are lesser, we can deploy that particular. Okay, so this is what we have understood in the today's lecture. Apart from this, I have to quickly show you our code also for this. So here we are importing all the required libraries. Okay, we are importing sklearn, we are importing from sklearn.model selection, we are importing train test split. We are importing sklearn.tree processing, we are importing one-hot encoders and standard scalars. Likewise, we are importing simple imputers, all these data pre-processing things we are importing. Once we have imported all these things, we are going to take this data set. Okay, let me show you. Okay, so we are going to take this data set. We are going to generate the synthetic. Here we have again taken a synthetic data set. Synthetic data set we have created. Okay, you can take a data set of your choice. Okay, which can be a publicly available data set or any other data set. Then we have splitted this data set into train, test, and valid. Once we have selected the data set into train, test, and valid, we have applied for numeric calculations. We have used missing values, imputations, and scaling we have performed. For categorical inputs, we have used the one-hot encoding. Then we have formed this encoders. After performing encoders, we have used this model for our use cases. Like we have used it for forming the embeddings first. Okay, we have used this embeddings and then we have used this model training. So here we are doing model training using Keras framework. So in deep learning, we are having TensorFlow framework, which is integrated with Keras also. And we are having PyTorch framework. So here we are using Keras framework. Okay, so we have integrated this with the Keras framework and we have used it, this model for, and we have used it for training. Now for the training part, we have used the evaluation matrix as MAE, mean absolute. See here, we have used this mean absolute error. Okay, for if our problem statement is regression. Since we have created this synthetic data set, guys, we have not taken this data set from any publicly available platform. Okay, so if our data set is having output variable, if our target variable is numeric, we can use regression task or regression evaluation matrix like mean absolute error, root mean squared error, R square. If our output variable is categorical, we can use with accuracy, precision, F1 score, all these things we can use. And then after this, we are just saving this particular model. Here we have run some epochs and you can see the accuracy of this epochs. Since our output variable here is numeric, we are having MAE as an evaluation matrix. Okay, so this is what our epochs are. So we have run this epochs totally and we got this ME, mean absolute error as this. Okay, we have to check with this R square value should be lesser than 0.5. All these things we have to evaluate. Okay, so this is it for today's lecture, guys. I hope it is understood. Okay. And for best reference, I will suggest you guys to go for, we are having this mind map. Okay, 360 digit MG having mind map. Okay. And we are also having this animated learning series. You can go through that also. Okay. Like which evaluation matrix we should put. Okay. All this we have in a GIF format. You can use that also. Okay. And for further details, you can contact our salesperson in this number. And these are all our branches. And we are also having franchisee branches in most of the parts in our country. Okay. So thank you. Thank you guys. Thank you for joining. I hope today's lecture was meaningful. Thank you for joining. We'll meet you with the new topic. Thank you.